Hi, welcome back. This is Professor Ridge, and today's lesson is on section 3.1, the complex numbers. The number I is defined such that I is equal to the square root of negative 1, and I squared equals negative 1. So we're going to start with that. So basically this comes from when we're studying quadratic equations, or if we're studying square roots, if we took square root of, say, negative 9, what squared equals negative 9? And then the answer would be there's no real number. Because any number squared is always going to be positive. So we had problems with that. So someone decided, all right, let's take care of this. Let's make up, since there's no real numbers, let's make some fake numbers. Let's make imaginary numbers. So we start off with the imaginary unit, which is defined up there. I'll write it again. Square root of negative 1 is I. So it basically starts from there. And if you square both sides, then you get I squared equals negative 1. So that's by definition. So this is a big idea. And then it turns out that all the properties that satisfy a number system are satisfied with this condition. And then we created a whole new number system. So we call it the complex number system. Now, I want you to take note of this line also. This is provided P is a positive number. Okay, so if you have a square root of a negative number, the way before you can do any radical rules, all the radical rules are defined where the radicand has to be positive. The number under the square root has to be positive. So if you have a negative number under a square root, you have to factor out the square root of negative 1, which is I. Okay, so you have to do that first. Always do that first. Okay, so let's try a couple examples expressed in terms of I. So square root of negative 7. Again, you're going to take out that negative 1. And you can skip that step. You can just go right to I square root of 7. Okay? Or you can write it square root of 7i. Now make sure that you don't put the I under the square root, which is a different number. So it's outside. Me personally, I prefer to write it this way. But some people write it with the I behind the square root. Alright, let's try square root of negative 25. So again, you're going to pull out the negative 1, square root of 25, so that's I times square root of 25 is 5, or we can write it this way, 5i, which looks better. So that's the preferred way. If I do the opposite of the square root of negative 23, we factor out the negative 1 under the square root, and that's I square root of 23. So it's negative I square root of 23. And then let's try negative, say, 50. So I'm going to pull out the negative 1. And normally I don't write that, I just go right to I. And then I'm going to factor 50, which is 2 times 5 times 5. I got a pair of 5s inside, so that comes out as a 5. And typically I write it this way. So any whole numbers that come out of the radicals I write in front, the I sandwich in between, and then the square root at the end. But of course, you can write it 5 square root of 2I like that. I prefer it, the one that I boxed, but you can write it either way. A complex number is a number of the form a plus bi, where a and b are real numbers. So a and b are real numbers. I is the imaginary square root of -1. The number a is said to be the real part, so the real part of a plus bi, and the number b is said to be the imaginary part. So complex numbers contain two parts. A is the real part. B, sometimes people say bi, but technically it's just b. So a is the real part, and then the b is the imaginary part. Okay, so a plus bi is a complex number. Now if b is 0, so if I had like 5 plus 0i, right, that just equals 5. So 5 plus 0i is complex number, 5 is a complex number, but we also know 5 is a real number. So this is just a real number, but it's still considered a complex number. Now if a was 0, let's say you had 3 plus I, so you get 3i. See, this is what, it's still a complex number, but we say that's purely an imaginary number. Okay, so again, it's a complex number, but since there's no real part to it, it would be purely imaginary. That's just, you may hear me say that, you may not, but that's some of the lingo. Okay, so what we want to do now is make sure that now that we know what imaginary numbers are, complex numbers, we got to make sure we know how to add, subtract, multiply, divide, simplify these things. So let's try a few. So if we want to add two complex numbers, so let's say -6 minus 5i plus 9 plus 2i. So what I always tell my students is, let's say you knew nothing about this I business being this imaginary number, and I just told you, hey, simplify this expression, -5, and think of the I as an x, right, if I were to put an x there. So if we didn't know that I meant something specific, and we were thinking of it as a variable, like x, how would you simplify this? And if you're saying combine like terms, so that would be right. 9 minus 6 would be 3. -5x plus positive 2x would be -3x. Well, there's no difference in when you're adding two complex numbers, you're going to add the real parts, -6 plus 9, and you're going to add the imaginary parts, -5 plus 2i. So we're going to get 3 plus 3 minus 3i. Okay, so it's just like combining like terms, basically. No difference. Alright, let's try subtracting. So if I had 6 minus 4i, that's a complex number, minus another complex number, -5 plus I. So for subtracting, again, if you didn't know that I was this special thing, and you just thought it was a variable, what would you do? And that's exactly what you would do with complex numbers. You're going to distribute the minus sign, so it becomes +5 minus I, and you're going to combine like terms. So we're going to add the real parts. 6 plus 5 is 11. And then we're going to combine the imaginary parts. -4i plus -1i is -5i. And it's just as simple as that. Okay, so adding and subtracting, no big deal. Now, how do you multiply if you're multiplying radicals like negative 49, square root of negative 49 times square root of negative 9? Now note, remember what I said before, you have to, before you can use radical rules, you have to take care of the square root of negative 1. Right, take care of that first. Before you do anything. So, you know, I always say take the I out. So, square root of negative 49 is I square root of 49. Square root of negative 9 is I square root of 9. So we're going to get I times I, which is I squared, times square root of 49 is 7. Square root of 9 is 3. So we're going to get I squared times 21, and then we need a note. By definition, I squared equals negative 1. So negative 1 times 21, which is negative 21. So you have to do that first. If you multiplied negative 49 times negative 9 first, because you know that's the way you're supposed to multiply radicals, you would get a positive number, which would be the wrong answer. So you have to take care of the I first. Take care of the square root of negative 1. You have to factor it out and write it as I. Alright, let's see how you multiply two complex numbers. So let's say 7i times 2 minus 5i. And again, if I gave you an expression like this and asked you to simplify it, what would you do? And if you said, okay, I would distribute the 7x, that would be right, 14x minus 35x squared. So again, this is exactly the same thing you would do with the complex numbers, is you would take the 7i and distribute it to both of those terms. Again, if you didn't know that the I was anything special, you would just go ahead and do it. 14i minus 35i squared. But here's where it deviates a little from the expression, is because we know by definition I squared is what? And hopefully you're saying negative 1. So then we simplify that. That's going to be positive 35. And then we got to write it a plus bi, so we got to write 35 first. And then the 14i last. Let's try a little harder one. What if we had two complex numbers like this? 2 plus 3i times 2 plus, how about 2 plus 5i? So again, if I asked you, if you didn't know that I was anything special, you just were thinking of it as a variable. Again, it's not. I is very specific. It's the square root of negative 1. But let's say we thought it was a variable for a moment. What would you do to multiply a binomial times a binomial? Hopefully you're saying distribute or FOIL. And that would be correct again. So 2 times 2 is 4, plus 2 times 5i is 10i, plus 3i times 2 is 6i, plus 3i times 5i is 15i squared. We're going to combine like terms. So that's 16i. And then remember the I squared is negative 1, so 15 times negative 1 is negative 15, plus the 4 in the front would be negative 11, plus 16i. Right, so that's how you would take two complex numbers and multiply them. Alright, so some special products from before, from polynomials, we know that a plus b times a minus b is a squared minus b squared. You get a difference of two squares. And we know that a plus b squared is a plus b times a plus b. When you FOIL it, you get a squared plus 2ab, because you get the ab from the inside, the ab from the outside, plus b squared. Now, how this relates to here, the top one, if you multiply, say, 3 plus 5i with 3 minus 5i, and you use that shortcut, we're going to go 3 squared minus 5i squared. You're going to get 9 minus 25i squared. But again, I squared is negative 1. So you get 9 plus 25, which is 34. And notice, it's just a real number now. So we multiplied two complex numbers, one a sum, one a difference, and we ended up with a real number. So we give this a special name. We call them conjugate pairs. Okay, so that's a conjugate pair. So we would say a minus bi is the conjugate complex, or the complex conjugate of a plus bi, or a plus bi is the complex conjugate of a minus bi. So either way, so conjugate pairs. Now, again, if you follow the shortcut, it's going to be a squared minus bi squared. So that's going to be equal to a squared plus b squared, if you just do the shortcut. So let's try a couple using the shortcut, this shortcut. So I don't care if you show this step here. You don't have to show that if you don't want, or you can show it if it helps you remember it, right? Because if you think of it as different squares, you show that step, or you can just skip it and just know that you're going to square the a, square the b, the I squared changes sign, so it becomes plus b squared. So if I had 6 minus 3i times the conjugate, 6 plus 3i, I'm going to get 6 squared plus 3 squared, 36 plus 9, which is 45. So it makes it real easy. Okay, so that's conjugate. And then if I square something, 4 plus 5i squared, that's going to give me 16 plus 2 times 4 times 5i plus 5i squared. I should have wrote that as 4 squared, but okay. 2, 8, 40 I minus 25. So where did the minus come from? Because it's 5i times 5i is 25i squared. The I squared makes the negative. So we get negative 9 plus 40i. Okay, so if I need to simplify negative 3 over 4 minus 5i, it's kind of like we did with radicals. You want to get rid of that square root on the bottom. Well, I is a square root. So what I need to do is multiply the top and the bottom by the conjugate of the bottom. So I multiply by the conjugate of 4 minus 5i, which is 4 plus 5i. Multiply that on top. So the top, you just distribute that negative 3, you get negative 12. So we distribute minus 15i. On bottom, we use the shortcut, so it's 4 squared, which is 16, minus 25i squared, which becomes plus 25. So 16 plus 25 is 41. and then we split it up into a plus bi form. So it's negative 12 over 41 minus 15 over 41 I. And so that's a plus bi form. Alright, let's try one more of these. So let's try 6 plus 5i over 3 minus 4i. Again, we're going to multiply by the conjugate of the bottom on both bottom and top. 3 plus 4i, 3 plus 4i. So we're going to distribute the top. So it'll be 6 times 3 is 18, 6 times 4i is 24i, 5 times 3i, 5i times 3 is 15i, 5i times 4i is plus 20i squared. The bottom would do the shortcut, 3 squared is 9, minus 4i times 4i, which is 16i squared, so it becomes plus 16, which is 25 on the bottom. And the top, now remember the plus 20i squared is equal to negative 20. So negative 20 plus 18 is negative 2. 24 plus 15i is 39i. And then split it up into a plus bi form. So negative 2 25ths. And of course, if it's fraction you can reduce, you reduce it. These two from C and D, I couldn't reduce it, so you just leave it as a fraction. So negative 2 25ths plus 39 25ths I. So that's a plus bi form. Okay, our last topic for this section is simplifying powers of I. So if we start off with I to the 0, anything to the 0 power is defined to be 1. So that's 1. Anything to the first power is itself. So I to the first is I. I squared by definition is negative 1. And I cubed, now we're going to do little exponent rules. I cubed is I squared times I, because if the powers are the same, if the bases are the same, you add the exponents. So 1 plus 2 is 3. And we know by definition I squared is negative 1. I to the first is just I, so we get negative I. I to the fourth, well that's I squared squared, which is negative 1, squared, which is 1. I to the fifth, now the way you do it is you want to take out all the I squares because that's negative 1. So what you do is you do 5 divided by 2 is 2 remainder 1. So the I squared, I take 5 divided by 2, it's 2 remainder 1. So 2 remainder 1. Well, that's negative 1 squared times I, which is just the I. And notice we're going to get this repeated pattern. We get 1 I, negative 1, negative I. 1 I, and this is going to be, my guess is 1 I, negative 1. Watch. So we're going to do 6 divided by 2 is 3 remainder 0. 6 divided by 2 is 3 remainder 0. So that's negative 1 cubed times I to the 0 is just 1. So that equals negative 1. So you see I, so you see the pattern there? So I to the 7th, I squared. So 7 divided by 2 is 3. That gets me 6 with a remainder of 1. So that's going to be negative 1 to the third power times I, which is negative I. Okay? So if I want to do I to the 54, I'm going to do I squared 54 divided by 2 equals, what's that, 27? Remainder 0, which equals negative 1 to the 27, oops, times 1. So if you have a negative to an odd power, negative 1 to an odd power, that's just negative 1. If you have a negative to an even power, that would be positive 1. So if I did I to the 148, that's I squared 148 divided by 2 is 74, remainder 0. So that's negative 1 to the 74. So that's an even power. So that's positive 1. Okay, if I did I to the 1, or let's say 237, that'd be I to 237 divided by 2 is 118.5, so that's 118 remainder 1. So that's going to be negative 1 to an even power times I, which is going to be 1 times I, which is just I. I to the, so let's see, say 323. So I squared divided by 2, 323 divided by 2 is 161.5, so it's 161 remainder 1, which is going to be negative 1 to an odd power, I, which is negative I. And there you go. So that's how you simplify powers of I, or you can say reduce power of I. Okay, so pretty straightforward, I hope. Some books suggest doing it in this pattern 4, and then you divide by 4 and see where you are in your remainder. That works great, but I think I like doing it with powers of 2. Okay, so I'm not sure how they explain it on the on the MyMathLab, but you can do it either way. Alright, so that completes the lesson for 3.1. Go to MyMathLab, complete your exercise there, and I'll see you next time.